Determining the epicenter distance using the wedge method. Imagine for a second you're sitting by a seismometer, and all of a sudden it starts to shake, signifying that an earthquake has taken place. You want to know just exactly how far away that earthquake was. Well, we can do this simply by looking at the report printed out by our seismometer. This is called a seismogram. Now, with a little bit of analysis, this simple diagram can show me how far I am from the epicenter. Here's how it works. First thing we want to look at is the first moment when the seismogram jumps. That signifies the arrival of the P wave. The second significant jump signifies the arrival of the S wave. Now, if we want to know how far we are from the earthquake, how far apart those two arrivals are can reveal that. So what we need to do is a little bit of simple math. We need to calculate something known as the lag time, which is simply the difference between the arrival of the P wave and the arrival of the S wave. Now, in this example, the P wave seems to have arrived at about 9:08 and the S wave at about 9:15. And that would give us a difference in arrival time, also known as a lag time, of 7 minutes. Let's keep that number in mind and take a look at our reference tables. Now, we're going to use a method known as the wedge method to figure out just how far away an earthquake is that would have a lag time of 7 minutes. To do that, we need some scrap paper. And what we'll do is we'll take our scrap paper and we'll align it with our vertical axis, or our travel time axis, on our reference table. And we're going to go ahead and mark off the lag time, which in this case is 7 minutes. I like to make a mark at 0 and a mark at 7, and I also like to label it just to make it very clear. Now, the reason this method is called the wedge method is because once we have the lag time marked, we're going to wedge it in between the two travel curves, the P curve and the S curve, until it lines up perfectly, keeping in mind that the scrap paper needs to remain perfectly vertical. Try and use the grid lines to help keep it in line. Once you have it lined up with the two curves, you simply follow that piece of scrap paper down to the bottom, and that will reveal the distance to the epicenter, which in this case appears to be about 5,400 kilometers. So, by simply looking at the lag time and using our reference table, we can figure out how far away we are from the earthquake epicenter. Something neat is true though. We can actually do the same problem backwards. Here's how that would work, and I'm going to use different numbers. Let's say we're faced with this question. A seismic station is 2,000 kilometers from the epicenter of an earthquake. How far apart will the arrival of the P waves and S waves be? So in this example, I'm giving you the epicenter distance and asking you to work backwards to find the lag time. Let's see how we would do this. Keep in mind that our distance, in this case, was 2,000 kilometers. So I'm going to locate that on the epicenter distance axis of my reference table. Now again, I'm going to grab some scrap paper and line it up on the 2,000 kilometer line, as such. Just like we did, but backwards, we're going to mark where the two lines are. And then we want to know how far apart those are, and that will give us our lag time. So I'm going to take it and slide it back down to the travel time axis. And however far apart they are is our lag time. In this case, it appears to be about 3 minutes and 20 seconds. So that's how we can use a seismogram to find distance, or backwards, we can use distance to find a lag time. This is a very important skill for the New York State Earth Science Regents exam, so make sure you practice.